In this video, I'll show you how to build a project that would be difficult to make if you had to start by modifying one of those sample projects from the chip manufacturer, like so many engineers struggle to do nowadays. Download our free guide to USB success. Secrets of Successful USB Developers. Hi, I'm Dr. Bob Miller, author of HIDmaker and Simple Upgrade Management System. The project we will build in this video was made with our flagship HIDmaker 32 product, but it could also be made with one of our low-priced HIDmaker Starter Editions. See the description for details. Here's what our project looks like when it's running. This USB project was made with HIDmaker 32. It can read the pod and push buttons of multiple USB PIC devices that are functionally identical, even though they are running on devices that may have substantially different PIC processor types. 8-bit, 16-bit, and even 32-bit devices are allowed. The PC program is a customized version of HIDmaker's generated PC code for this project. The generated PC program looks like this. Rather plain looking, but fully functional, and easy to customize in modern PC compilers to make it look and act like you want it to. By some rather simple design changes in the PC compiler, we customize a copy of the generated PC code to look like this, using nice-looking third-party screen controls from TMS software. You can see that when we connect a second device, another gauge automatically enables and shows the position of the pot on that second board. The PC program is now reading both boards, having a separate communication with each board, so when I rotate the pot on either board, the corresponding gauge on the PC program changes. This ability to automatically read multiple devices of the same design is built in to HIDmaker. Now, HID class is widely recognized as the most flexible and user-friendly USB protocol that can make the widest variety of projects, which can be recognized instantly by any PC. But HID devices can be complicated to make. Code generation is the thing that lets you get more of something without spending more money. If you put HID class and code generation together, that gives you enormous power. That's what HIDmaker does for you. HIDmaker is the quickest and easiest way to make a known good USB project that is guaranteed to work end to end right away for your custom data. So let's get started making this project by starting HIDmaker 32. The first thing we notice is that there is extensive help of several kinds, not just about how to run HIDmaker, but also advice on USB strategy, so you can get the most out of the USB capability. And our USB advisor will pop up from time to time to guide you if needed. We only need to generate the simplest kind of USB device type for this project. On the project page, we create a project directory and fill in some project properties. On the next page, the main thing we need to do is to define our data. HIDmaker uses direct transfer of variable. You define the data you want to send between the PC and the PIC device down to the level of individual transfer variables. You give these variables names that are meaningful to you. We'll name one variable pot1, which will contain the pot position read by the PIC device. Those transfer variables that you defined get packed and unpacked automatically at both the PC and PIC side by the HIDmaker software framework. So there's never any guessing where each data item is in each packet. When we have defined all the transfer variables we want, we save the data and go back to the configuration and interfaces pages of the HIDmaker wizard and set which USB endpoints we want to use for this USB interface. On the next page, we see that HIDmaker can generate custom source code for your favorite compilers. We can generate code for all of them if we want. It only takes a few seconds. We choose at least one compiler on the PIC side and at least one compiler on the PC side, and then we click Next to generate our code. Then we can see all the code we generated, both for the PIC side and the PC side. Thanks to the HIDmaker software framework, the generated source code is profusely commented and easy to customize, yet extraordinarily powerful. HIDmaker's generated PC code is object-oriented, like all modern PC software. In our generated PC code, our whole device is an object, and each variable, like pot1, is also an object that is owned by the device object. All of these software objects have properties, methods, and events. HIDmaker's generated code is ready to compile and run, and is guaranteed to be able to correctly send the types of data that you defined over the USB. But since HIDmaker cannot know what I/O pins and peripherals your PIC device will use, the generated code only sends test values. Since HIDmaker cannot know what your PC program should look like, it generates a rather plain-looking but fully functional graphical user interface that displays values as text. This plain-looking user interface is easy for you to customize, so you can make the project look and behave the way you want it. At this point in your work, we recommend that you compile and run both the as-generated PIC code and the as-generated PC code at the same time so you can see that everything is working. Then, the next step would be to add a little PIC code to actually read the pot voltage and push button states on the PIC board and put those values into the appropriate USB transfer variables. That lets the HIDmaker software framework automatically pack them into USB packets and send them to the PC. At this time, you would also add some PIC code to actually light up LEDs from data values sent from the PC. Once you make those simple PIC code mods, your as-generated PC program will now show live data that changes when you turn the pot or press push buttons on the PIC board. For this project, we went through several customizations of the PIC code to display the data on the PC in different ways. First, we used stock screen controls that came with the compiler. Then we tried some third-party screen controls we have, but still displayed data from only a single PIC device. And then finally, we made a version that can display data from multiple PIC devices at the same time. Question of the day: what kinds of things could you do with USB HID if you could get them working quickly, easily, and inexpensively? Thanks for checking out this video. Please subscribe if you're not already subscribed. If you want to, check out that free Secrets of Successful USB Developers guide with tips on getting your USB projects working end-to-end, really fast, every single time. Click or tap the screen in the description below. As always, we're helping you build your knowledge, skills, and impact with online video. Talk to you soon.